Okay, we're good. Thanks everyone for coming. I know it's super nasty outside, but let's talk about Active Record. So is there anyone here who has used Active Record before? Is there anyone who has used something similar maybe in another language, a different ORM? A few people, okay. Cool, well, great. So my name is John. I've been a Ruby programmer for a long time, and I like a lot of other things outside of Ruby that I'd rather talk to you about, but this is a Ruby group, so we're going to talk about Ruby stuff. So here's what we're going to talk about. We're going to talk about what Active Record is, how you work with it using migrations, how you query it, how you set up relationships and data validation, and then some other stuff that I couldn't think of a title for. Okay, so what is Active Record? Active Record is Rails ORM, and it is a way that we can basically translate our Ruby code into database values, and then our database values back into Ruby code. So it provides this abstraction layer that makes it really nice and easy to work with the database. The name itself probably comes after this Active Record pattern, which is something a guy named Martin Fowler kind of coined. He's a very prominent programmer, author, speaker, kind of software engineering as a whole conceptual guy. And it's translating in-memory data into relational database rows. So you might have heard this, or you might hear the term ORM, object relational mapping, same thing. We have Ruby code, or we have JavaScript, or Node, or Python code. We want to translate that into database stuff, and then vice versa. Okay, so the number one way that we interact with our database as far as changing it, messing with it, at a structure level is through this thing called migrations. So let's say you're starting a new Rails app. So you have Rails new, and you do Rails DB create. So you have this new database on a new Rails app. And what that gets you is basically two empty databases. You have a development one, then you have a test one. And so for this talk, I wanted to kind of have a little app that we could be making to kind of have a flow of what we can work through. And so what I'm calling this is, we're going to make this app called People and Pet Pals. And it's this app that lets owners and their pets keep track of their information. What pets do you own? Who belongs to that pet? Like a basic database system around people and pets. So to start, we'll make a user model. And to do this, we use the Rails generators, Rails G model user. We have a field called name, which is a default of string, email, which is default string, and then an age, which is an integer. And this makes a lot of files for us, and one of the things it makes is this migration file, db/migrate/ the timestamp that you ran the command, and then what you're doing, so create users. And this file looks like this. It is a Ruby class with a change method, and then it gives us this way to change our database schema. So here we're creating a table called users, and we're specifying our 3 columns with their types, and then the timestamps creates a created at and an updated at column for the table. And the reason we use migrations is very similar to why we use Git for our code. So we don't just YOLO on production servers with our code like FTPing things anymore, because we realized like that's bad. You don't know what state the code's in. If you pull down my project, like there's no way to tell what has happened. So migrations are very similar to that in that they're systematized snapshots of the changes we want to make. So if I'm changing my database locally on my project and you pull it down, then you want to be able to replay the same changes that I made. And so the migration does this. So when you migrate this migration using the command Rails DB migrate, it goes through all of the migrations that it hasn't run and migrates them. So if you run it twice, Rails internally keeps track of which migrations you've run, so it doesn't try to do it again, because you only need to create a user table once. You only need to add or drop columns one time. So migrations are the tools that we use to change the structure of our database. So just with running that very simple migration, the database now looks like this. So we have a users table, and then we have these 2 tables that Active Record uses internally to keep track of the state. Now, one of the things that we got with that generate command was this user model. And right now it's blank, but it's just a class called user, and it inherits from this class called application record. And between Rails 4 and Rails 5, there was this, for all of our states and purposes, active record and application record are the same thing. They introduced this kind of intermediary if you want to change some stuff kind of like at the base level, but you don't want to change like active record base, which affects everything. But for our intents and purposes, it's the same. And so what this does is by inheriting from this class is it gives our user models a lot of really nice things when it comes to querying. And so if you're familiar with simple database statements, selects, where, order, group, all that kind of stuff, by inheriting from active record base or application record, we get all these nice helpers that let us do the SQL stuff without having to write SQL. So for example, if we wanted to get all of our users, it injects this method called all. So user.all translates into what we would think, select star from users. And right now we don't have any, so we just return an empty active record relation, which is basically like a fancy array. And we'll talk a little bit more about that in a second. So let's make some users. So just like we have .all, we also get .create. And you just have to pass the properties. So we're passing a user with a name, SusieQ, email susie@q.com, age 25. And so when we run that command in our console, we see that it translates that into an insert statement. So insert into users, all the stuff that we need. Similarly, if you want to find that user, we have the find method. It takes an ID. So find user.find1 returns our first user. We can also search based on specific clause. So we could look for users where the email is a certain thing, and then we could take the first one of that. And it comes with all these other methods that you would expect to be in any ORM or database thing. Like you can order stuff, you can group stuff, you can find and destroy things. And then at the bottom, you can, because it returns an active record relation for most things, you can chain them together. So you can build up the query all at one time and then execute it. Okay, let's get back to our example app. So a user has a pet. So let's make a pet real quick. Same thing as a user, Rails G model pet, give it a name and an age and a type. We get the same type things. We get a database migration file. We get this class called pet, and right now they're just empty classes. We have a user, we have a pet. So how do we make these two things relate to each other using active record? So Rails has an entire doc on relationships. They call them associations, and it's really good, so definitely check that out if you're working with active record. I'll give you a lot of examples of how to not only set up your structure, but set up your models to work well. So if we just said this in English, like Kimberly mentioned, we use this has and belongs type language. So Rob has one pet named Spike. Spike belongs to Rob. And these make a lot of sense to say in English, and it also makes sense in our database. So the question is, we have these users and we have these pets. How do we, at a database level, link them together? And if you've done any type of relational data modeling, what we do is we add a user ID and we scream in the other room really loud. So we add this user ID, and it points our pets over to our users. And so to do that, just like any other database change, we add a migration. Rails G migration, add user ID to pets. We'll migrate that. The migration looks like this. Add a column to pets, user ID, which is an integer. So now if we make a pet, pet.create, give it a name and age and a type, and then we pass our user ID. Okay, so now we have these things set up correctly in the database, and we need to tell Rails, this is the type of association we're dealing with. And so very simply, we just put exactly what we would think we would say. A user has one pet, a pet belongs to a user. And so because we've told Rails, this is the type of association, it knows how to go look for those tables based on the name, and based on which relationship it is, it knows how to look for the ID. So it says, I've got a pet, it belongs to a user, so I'm going to look at the pets table, and I'm going to look for a user ID, and that's how I'm going to link those together. So now if we do user.pet, we have that link form. So we can have a user get his pet, and then vice versa, if we have a pet, we can find their user. And just as a little side note, you can also choose when you destroy the parent record, what do you want to do with the association? So if you delete the user from your system, you can also delete the pet. Okay, cool. We have a person with a pet. That's great. But the scenario probably looks more like this, like people have more than one pet. And also, multiple people have different pets that belong to each other. So like, we got to go a little further. So looking at the first case here, a user has many pets. What if I told you this was just a one-line change? I would tell you that because it is. So a user has one pet to a user has many pets. Done. If we create a couple of pets for the same user, add 3 more pets, and then we do user.first.pets, we get all their pets back. So between has one and has many, the database structure stays the same. Okay, now I know you're thinking about this. You're like, what about this? And more importantly, who is this? And what is her story? And that I don't know. But this is a valid case. So people can belong to different pets, and the same pet can have 2 different owners. So here's where we get into our many-to-many, or as Rails calls it, has and belongs to many. So you'll see it abbreviated like that sometimes too. So this is from the Rails docs. Similar to what Kimberly showed, we have this join table. We have this intermediary thing that will point a user to a pet and vice versa. So just to look at a quick example, if we have Susie who has a pet named Buster, they have an ID, so right now Buster has a user ID, which is great. But when we add a new person, say, oh, Jim also owns Buster, we have a problem here because maybe we could like add another user ID, but I mean, what if someone has 3 pets, then you're adding more columns? Like this obviously doesn't work. So like Kimberly showed, we need this intermediary thing. And this intermediary thing we're calling pets users, and it just maps these 2 things or relates these 2 things together. And so that way, they can both belong to the same pet, and then if Jim gets another pet on his own, he can also independently own that one as well. Now, to make a has and belongs to many migration, if we were moving from our current point, you probably wouldn't do this right out of the gate, but we would remove our user ID from pets because we don't need that anymore. And we would create this intermediary table, pets users, and it belongs to the user, it belongs to the pet. Now, Rails is very specific on the naming of things. It's convention over configuration. If you set it up correctly, it does magic, and it blows your mind. You don't know how it does it, but it works. And so by default, Rails expects this join table to be alphabetically the 2 table names put together. So you might think it'd be called users pets because the user has the pets, but it's pets users because P comes before you. I think you can change this as like an option on the association. You can say this table is the join table, but that's one little gotcha if you're doing this for the first time. As far as changing our models, again, a one-line change. Has and belongs to many pets for users. Has and belongs to many users. So now if we try this out, we have a user that we're going to use find by. Let's find by their name, Susie. We can add a pet to Susie using the shovel operator, angle bracket, and we can see that it inserts into our join table our pets users. Same thing with Jim. If we create a user called Jim, we give him 2 pets. If we look at Susie's, we can see that she has a pet with an ID of 2. We look at Jim's, he also has a pet with an ID of 2 because he belongs to the same one, but he also has an extra pet with an ID of 6. Okay, changing gears a little bit. Like Kimberly mentioned, keeping your data valid is incredibly important. If your data is invalid, your database is worthless, and it's going to make programming on top of it a huge, huge pain, if not impossible. So Rails provides some things called validations, and they make it easy to make sure your data is correct at the Ruby level. And so we might want to require that our users have a name or that they have an email. And so if you try to save a new user, user.new.save, I didn't pass any attributes, it returns these validation errors. Gotta have a name, gotta have an email. And these validations are really great for, at the user level, being able to tell your end user, hey, you gotta give us a name. Because when you try to save, here I use the exclamation point version, save bang, so it threw an error, but if you just do regular save, if it fails, it will populate the error messages on the user model, so when you you can show this to the user. Hey, you need a name, you need an email. And there's all different kinds of validations you can do. You could check that the email has an @ symbol. You could check that the the age is only an integer that's greater than 0. You could check that it's less than 120. You can help keep your data in a good spot. And this is really amazing, and you should definitely put this in all of your apps. But like Kimberly mentioned, this is not enough. You need something at the database level to stop bad data from getting in, just period. There are problems with validations. Let's say you had an email validation you wanted to be unique. So you can't have the same email for a user. While it is unlikely, you could have 2 requests come in at the same time, both check for an email validation uniqueness and pass, and you get what's called a race condition, and so both would get inserted. It's also not hard for someone to accidentally comment out that validation. Maybe that validation uses a method that does logic to determine validity. They mess up that method. It's possible to just not have it work. And so what you need are database constraints. And these are things that are at the database level that will error and not allow bad data to come in at all. Now, when I set this up, I took away some of this just to keep the example simple. But usually when you're building a new table that references something, if I was going to make pets again, I would do Rails G model pets, user :references. And so this is telling Rails, hey, this is a foreign key to another table. Like this user ID in the pets table, it has to match a user that is in the user table, or we have a really big problem. And so the migration that's generated from this looks like this. T.references user, and it tells it this is a foreign key. This is something that I have to have exist in the other table, or it should error. And if you look at the database after you migrate that, you see that we have a foreign key that points back to the user ID, which is what we want. And then we also get this other thing for free. We get this index on the user ID. So we're probably going to be looking up pets based on their user a lot. So we get this index that will make it fast. To show the example for an email uniqueness, you can add a unique index on the user column or the user table. So add index users, email, unique, true. So now, no matter what happens, we're not going to get duplicate emails. Okay, a couple miscellaneous things before we wrap up. There are times where you want to do some querying and you want to bring in another table to do some filtering. So for example, let's take a use case. I've got users with really old birds as pets, and I want to send them an email saying, get 50% off your next bird, like get Polly a friend or whatever. And you want to take these users and you want to bring in the pet data and you want to do some filtering, but you really want the user in the end. Like you don't want to keep this pet data around. And so you might join on this table. Go watch Kimberly's talk on joins to see how that works. But we're basically taking the user record, the pet record that matches, put them together, and now we have that entity to query on. And so we can chain these methods together again. User.joinsPets, where the pet is a bird, where the age is greater than or equal to 10. And let's get the oldest pets at the top so we can get those out soon. And this is great. This works great, and it allows you to do some filtering. Now, there's a common problem with active record queries, or just ORM queries in general, and it's called the N+1 problem. And it's very easy to fix, but it's also something you have to watch out for. So let's take this example view. I have all the users in my database, and I want to display all the users, and I want to display all their pets at the same time. So I do users.all. I'm going to iterate over all the users. I'm going to put their name on the page, and then I'm going to iterate over their pets, put their pet name on the page. Simple enough. The problem with doing this is that these are the queries that are made from this. We see one user query where we got all the users, but then for each user, we fire a separate pets query. So for every user, we're doing another query, and this is where we get the N+1. We have N users plus 1 for the original user query, and this will take simple and not complex apps and grind them to a halt, because database query connection round time that it takes is very expensive. It's one of the most expensive things of your request. And so if you have 1,000 users, you made 1,000 database requests. And that's a problem. But it's very easy to fix this with Rails. You just have to say, when you're querying, instead of user.all, user.includes pets. So I'm going to want this pet data, so go ahead and give it to me now. And the result there is that we have one query for users, and then it does a pets query, but it takes all the user IDs that we already found, and it looks for all of it at one time. So here we go from 10 or 1,000 pet queries. Now we're down to just one, so there's 2 queries total. Again, not a hard problem, but if something's acting like kind of slow, this could be a very likely cause. Last couple things. There are escape hatches. Active Record is amazing, and you can do a ton of things with it. And there are some times where it's a little painful, like if you have a really kind of complex analytics or data roll-up query that you're trying to get done, it can be kind of a pain to use all their methods. And so there's a couple escape hatches you can use. So instead of joining on pets, for example, you can use a string in the join and just kind of go to town in there. You can put whatever you want, joins, groups, subqueries on subqueries, just whatever you want to put in there. And so that's a useful escape hatch. The other one is you can also just execute raw SQL, which is like, you might want to be careful with that, but if you need to, you can select star from users, call .toArray to make an array out of it, and you can get what you need. So with that, I'll close it up. I'm at John Mosesman everywhere. If you want to talk or be like, man, that guy sucks, he doesn't know what he's talking about, you can do that everywhere online. What questions do you have? Mr. Aaron.
What's the competitor in Active Record or some other option tool? Or is Active Record like the thing?
So the question is, what is a competitor to Active Record? I don't even know if I can think of one. Like, Active Record is just the thing that I've always used and that people use. Do you know of one?
I heard of one called SQL. No, just SQL. I think it's called SQL. But I've never used it or anything. I don't even know if it's still around.
Huh.
Is it still around?
There's some conversation that it is. Granted, I've been doing Ruby for like 8 years and I've never heard of it. So that maybe tells you its state. Okay. Audience says if you're doing crazy SQL stuff, you might want that to fill in where Active Record's a little too restricting. Matt.
Yeah, so if I'm trying to learn Active Record, is it helpful to go learn like vanilla SQL querying first, and then learn like Active Record is kind of the shorthand? And if so, how would you go, like if you were going to learn Active Record from scratch, what would you learn, in what order, and why? How would you go about it?
So the question is, if you were wanting to learn Active Record, would you learn SQL first and then that, or like how would you go about that? And I think Active Record is so nicely set up that I would just build your Rails app, and through the process of creating your app, you're going to come across 95% of the things you would ever want to use, and then you'll come across something where it's like, oh man, I really need user emails to be unique because I accidentally signed up twice with the same email. Then you would go find that thing, and you'd be like, okay, how do I do this? Okay, I can add an index. What is an index? Index correlates to this in the database. So I don't think you need to go learn database stuff first. I think that'd be great. I mean, the more you know about that, the better. But I think just building your Rails app, you're gonna figure it out. Yes.
Question about the speed that you were mentioning in terms of like querying one twice instead of multiple.
Right.
What's the difference? Like, how does it save you time?
So the question is, how does this approach save you time versus, or how does including it save you time?
Because you're still making the query, you're still pulling everything from the database, right?
Right.
So you're still having to take that cost of reading everything.
Right. So the question is, how does including the data eagerly give you the performance gain? And the reason is the number of connections your app has to make to the database to get the data. Database querying is like crazy fast. And so the slow part is your app having to make a connection, like maybe there aren't any open connections, maybe you have to wait, get the data, come back, close down the connection, and do that again 1,000 times. Whereas if you ran just that query 1,000 times, like the query is incredibly fast. So it's really just the time to build and then send the data over that connection is what gets you.
So this would pull pets into like a local memory.
I'm sorry, one more time? Uh-huh.
pull the pets database into your local memory?
So the result is the same. When you do user.all, it does the query and then builds these user objects. The result is the same, but the difference is when you don't include, when it comes to this page right here where you're iterating, here I'm going, for every time I go and ask for the pets, it looks and says, oh, I don't have this, I gotta go get it. And so it goes and gets it, and then the loop iterates, and then it goes and gets it again, and then it iterates and it gets it again. Whereas with the includes, it gets everything all up front. And so it doesn't have to make that extra trip every time. Does that make sense? Yes?
Does it do input sanitization to help protect against things like SQL injection?
That's a good question. I should have had a slide for that. So the question is, how do you protect against SQL injection? And there's a way, we're gonna go off the grid real quick. Oh, nice. Okay, this works. So usually when you do like a where clause, so you do something like this, like look where the thing is the variable, and the user can maliciously put whatever they want as the name. Like they could put extra SQL right here, where it's like drop table, whatever. And so they can basically close up your SQL string and put something malicious. And so what Rails does is they provide this way to sanitize stuff. So if you would say like where, and then you put it in strings and say name equal question mark, and then you put the var out here. I think I typed something wrong. Typing with delay is fun. And so you do it like this, where you're saying, this is input, this is untrusted input, and so Rails will escape that within the where clause. Good question.
I think escapes the other.
So it,
I think escapes the first way too. This is in addition to that.
okay. So it may escape it as well the other way, but I know that this will guarantee to work. Anybody else? One in the back.
The alternative to active record is called the data mapper pattern.
Okay.
And I would look at that's a folder. So
An alternative active record data mapper pattern. Okay. I'll have to check these out. All right. Thanks, everyone.